guys, and today we are going to be talking about density of a gas at STP. That is kind of a very important part that we have here is STP. Remember, we haven't really gone over this too much, but it's standard temperature and pressure. That's about all you need to know at this point, right? So when we're talking about density, just a quick reminder, you've seen density already, but this is mass over volume. Since we want to use correct scientific language, we're going to go over the definitions of mass and volume. Hopefully you remember that mass, in red over there, is the amount of matter present in an object. So how much matter there is in an object, all right? Typically, actually always, we measure mass in grams. Our volume is the amount of space that an object occupies, all right? So how much space it takes up, and we measure volume in liters, okay? So we're going to be dealing with grams and liters today. Now there's two methods for calculating density of a gas at STP. It has to be at STP. The first method is dimensional analysis. I'm just going to underline this. Dimensional analysis. So here's our example. A sample of methane gas, which is CH4, has a mass of 70.0 grams at STP. Calculate the density of the methane gas. Great. So over there by Miss Thomas, you'll see density equals 70 grams, right? We know a mass. Our mass is right here. 70 grams over volume. We don't have a volume yet, right? All we're given is a mass. So we need to find the volume. Now, I've already done step one for you, finding the volume, because you guys have already done dimensional analysis. So we're starting with 70 grams of CH4. We put our grams of CH4 on bottom, and this is the molar mass of CH4. I already calculated it for you. And the mole goes on top. Remember, if mole is not part of it, we have to go to moles first. So grams of CH4 is gone. 1 mole of CH4 on top. We have mole of CH4 on bottom. We're trying to get to liters, right? We're trying to find the volume. So what's the volume of 1 mole of a gas at STP? 22.4 liters. So 22.4 liters goes on top. Mole of CH4 cancels out. And when you calculate it, you get 97.7 liters of CH4. Okay? Great. So now we know a mass and a volume. We can calculate the density. Okay? So we're going to plug in our numbers. Density equals mass over volume. Our mass that we're given is 70.0 grams. Our volume that we just calculated is 97.7 liters. Now, because I'm just very particular about this in class, I didn't say it. But I want you to write it. Grams of what? Grams of CH4. I didn't say it, so you didn't write it. Sorry.
Oh, no, that's fine.
So grams of CH4 over liters of CH4. And when you calculate it, you get 0.716 grams over liters CH4. So we have our density of methane. Great. That's method one. Not too bad. We've already learned dimensional analysis. Now, step two, Ms. Thomas is going to walk you through. Oops, that's going to hit.
Got it. Okay, the second method is using the molar mass and the molar volume, and I'm going to explain what that actually means in a couple minutes when we get down to the actual calculations. But essentially what we do is we calculate the molar mass, and then we use the molar volume, which you're like, okay, what is that? But it is just 1 mole of a gas at STP, remember, is always equal to 22.4 liters. So we use that equivalency statement to plug into our density formula. But first, we got to calculate the molar mass. So we're using the same problem, just so you guys can see that we get pretty much almost the same answer, depending on our rounding. But a sample of methane gas has a mass of 70 grams at STP. Calculate the density of the methane gas. That is not a question. Okay, calculate the density of the methane gas. First step, calculate the molar mass. Now, looking at the periodic table, I have 1 carbon atom, 4 hydrogen atoms, all together, multiply, add 16.05 grams per mole. Now remember, this is always our unit for molar mass, so we have grams per mole. The second step is pretty straightforward. Calculate the density. We use our density equals mass over volume, and then I plug in my mass, which was given in our equation. Oh, sorry.
Plug in the molar mass.
I plug in my molar mass. I plug in my molar mass, which I literally just calculated, grams per mole, and then I am going to use my molar volume. Now, remember that that my molar volume, I just said it a few seconds ago, but my molar volume is equal to 22.4 liters per mole. Every mole, 22.4 liters. That's how much space it takes up, a gas takes up at STP. So you can see this is our like updated version of the density formula. Just another way of representing it. And so I will put my 22.4 liters per mole down here. And you can see that my moles actually cancel out. So that's how we end up with the grams per liter, our normal units that we want when we're talking about density. So all I do is I put 16.5 into my calculator, divided by 22.4, and I end up with 0.717 grams per liter. Grams per liter, because my moles canceled out. You can see our last one, because of rounding and sig figs, it was pretty darn close. That is the density of methane.
That's it for today. Hope you enjoyed the short video.